In this video, we will be looking at the binomial theorem. So I'm going to piggy off of the last video where we talked about Pascal's triangle and using that to do our binomial expansion. And just to review, this would be row 0. You would have 1 as your final answer, so one term. So this is one term. If the exponent is 1, your final answer would just be a plus b, so 2 terms. If the degree or n is 2, now you have a plus b squared, and you end up with 3 terms. You can kind of see this pattern all the way down, 4, 5, and now 6 terms. So 4 terms, 5 terms, and 6 terms for the row. So if n is 5, we actually end up with 6 terms. And that's important for us. So there is another way to get any number for the coefficient, and that's using combinations. So we're going to look at that today. The binomial expansion, called the binomial coefficient or identity, describes the coefficients in the expansion of a plus b to the power of n. So the binomial expansion for a plus b to the power of n for any positive integer n is a plus b to the power of n equals nc0, n choose 0, a to the nth, b to the 0, plus n choose 1, a to the power of n minus 1 times b to the first, plus n choose 2, a to the power of n minus 2, b squared, so on and so forth, all the way up to n choose n, a to the 0, b to the nth. This is sigma notation, which means you're going to be adding up terms in a series, and that's something that you'll be doing next year in pre-calculus. And then our pattern is you're starting with an R value of 0 and you're going up to n. And that's, you need to start at 0 because there's one more term than n. And that's a pattern that we're going to see over and over again. And then you will have n choose r. So remember, we started with 0. Remember, n choose 0 is 1. And the first term always has a coefficient of 1. And then if you have n choose 1, your coefficient will always be n. And that's why here you get the 5, the 4, the 3, the 2. Okay? And then here your first term has a decreasing exponent, and the last part of the, I shouldn't say term, but the next part of the first variable has a decreasing exponent, and then the second variable has an increasing exponent. Okay, and then that means the r plus first term of a plus b to the n is n choose r times a to the power of n minus r, b to the power of r. All right, so this is kind of a lot to work through. So we're going to find the first five terms of x minus y to the power of 8. So the first term is always pretty straightforward because you're just going to take the first piece of your binomial and just raise it to the degree. So n here is 8. Okay, so I'm going to have x to the power of 8. And now my first exponent will be 8, and I'm going to put a positive here, and I'm going to have x to the power of 7, and now negative y to the power of 1. And if I wanted, instead of writing the 8, I knew it was going to be 8, but I could write it as n choose 1, or 8 choose 1. This could be 8 choose 0. 8 choose 0 is always 1. And now I'm going to continue with that pattern. So 8 choose 2, x to the 6th, negative y squared. Here's my first term, my second term, my third term. My fourth term is going to be 8 choose 3, x to the 5th, negative y will have an exponent of 3. 8, 7 plus 1 is 8, 6 plus 2 is 8, 5 plus 3 is 8. So I'm liking my pattern. This is 4. And then finally, 8 choose 4, And if I wanted, I could write it as 8, choose 4. So they're saying the same thing. It's just a preference. I use them interchangeably. And then x to the 4th, and now negative y to the 4th. And this is going to be my 5th term. I'm only asked for the first 5 terms, so I'm going to stop there. Okay, and now you can see why when you're looking for a particular term, you always add 1 to r. So here, r would be 0, but I'm going to add 1 to it, okay? R would be 0, okay? And that would be 8, choose 0, and then you would use that in your formula, okay? All right, so this is finding my first term. So my final answer is going to be x to the 8th minus 8 x to the 7th times y. So since the negative had an odd exponent, I keep the negative. Now 8, choose 2. I have these done out for you, so I'm not going to ask you to grab the calculator. That's going to be 28 x to the 6th y squared. This was a negative variable with an even exponent, so that became positive, whereas in the next one, this is going to be negative. So I'm going to end up with a negative. 8, choose 3 is 56, so I have negative 56, x to the 5th, y to the 3rd, and then that repeating pattern of positive, negative, this next one's going to be positive. 8, choose 4 is 70. X will have an exponent of 4, and y will also have an exponent of 4. A negative expression to the power of 4 will keep that, we'll change that to positive. Okay, and so this is 1, 2, 3, 4, 5 terms, and that's all that I needed to do there. Okay. The next 2 questions are saying find and simplify the 7th term in the expansion of 2x minus y to the power of 10, and then find the term containing y to the 3rd in x minus 3y to the power of 8. I actually think number 3 is a significantly easier question than number 2. So let's start with a harder one. You have 10 for n equals 10, so that means there will be 11 terms. And if you want the 7th term, that means r will be 6. And if you can keep your head straight around that, you will have a lot of success. Okay, so that's really the trickiest part here as you go through. So just remember here, the first term, r was 0, r was 1, r was 2, r was 3, r was 4. So even though I was looking for the 5th term, I dropped it 1 to keep going. And I always like to point out that r corresponds to the second variable in the original binomials exponent, and that really helps us a lot. So if I want the 7th term, r is going to be 6, so r equals 6. So now I'm going to do 10, choose 6, and then I'm actually going to go backwards. So I'm going to start with a negative y. Negative y has an exponent of 6. The 2x has an exponent that will, when added to the 6, equal 10. So this is going to have an exponent of 4, because remember, the sum here is always 10. So once I have r is 6, I use that for the part of the combination and for the second part of your binomials exponent. And then it's just calculating. So 10 choose 6 is 210. 10 choose 6 is 210 on a calculator. Then you're going to get 16 times x to the 4th. A negative y to an even exponent is just going to become positive y to the 6th. Okay, and then I do have to multiply the 210 and 16, and when I multiply that, I get 3,360 x to the 4th, y to the 6th. I'm only looking for one term. I'm looking for the 7th term. So the 7th term will have an r value that's 1 less. I personally think that a question like number 3 is easier, because it gives you what r is. So when you are finding a term containing y to the 3rd in x minus 3y, I know r equals 3. And that helps a lot because, and if you think that out, I would have negative 3y to the third. This exponent here has to be the 3. And remember, those are always going to be in alignment. So this r goes with that r. So that pairing is really, really convenient because then I would know I would have 8, choose 3. And then the x here, remember, these add up to 8. So this is just going to be 5, and then you're good to go. So you're going to do 8, choose 3 on your calculator. You would get 56. I'm going to have x to the 5th. This negative 3 will have the exponent of 3, so that's going to turn into negative 27. And then remember, the exponent is applied to both the coefficient and the variable. So I get the negative 27 and then y to the third. And then you just need to take it one more step and do 56 times negative 27. You get negative 1,512, x to the 5th, y to the third. Always verify that these add up to the n value. They do. So this is 8. So that's a good sign. And then y had an exponent of 3. And that was the criteria that I was looking for. So this is actually the 4th term in the binomial expansion. And that occurred when r was 3 and when y had the exponent of 3. All right. Thanks for watching.